this is the class for the student those who are appearing for the compartmental examination. In the last 2 days I have shared the notes of the matrix chapter and some videos of the matrices also. Today I just will summarize this chapter. What are the important concepts in this chapter? Just to summarize, and you should just go through this video, and I think some 5-6 assignment I has given, and one more assignment I will be giving you. So by this week you should complete the chapters. So one is about the definition of the matrix. You know that the definition is the rectangular array of numbers. Matrix is a rectangular array of numbers or rectangular array of things, whatever. And systematically arrange the numbers or things in a rectangular way. That is, rectangular means there will be the rows and the column way. That is called the definition of it. And then it is order of matrix. When you arrange a matrix, that is in the numbers in the rows and columns, say 1, 2, 3, 4, 5, 6. I have arranged 6 numbers in 2 rows and 3 columns. This is row and this is column. And we say the order of this matrix is 2 by 3. And we write like this, 2 by 3. So when you say that the matrix of order 2 by 3 means it contains 2 rows and 3 columns. The number of rows and number of columns decide the order of the matrices. Is a general way of writing a matrices is A is equal to, suppose A is equal to Aij is of an order m by n. That means it is a matrix having m rows and n columns. Or if you write it this detailed way, it will be A11, A12, etc. A1n, A21, A22, etc. A2n, etc. Last AM1, AM2, etc. AM. This is the m row and n column matrix. So that is the definition, order of the matrix, and the representation of the matrix. Either we use this square bracket or we may use this vector also for representing. And then the next point is about the types of matrix. What are the different types of matrix? One is zero matrix. That means if all the elements of the matrix is 0, we call it a zero matrix. Then square matrix. What is a square matrix? If the number of rows and number of columns are equal, then we say that that means 3 rows and 3 columns, or 2 rows and 2 columns, 4 rows and 4 columns. Such type of matrix are called square matrix. Then diagonal matrix. What is a diagonal matrix? It is a square matrix. Always diagonal matrix is a square matrix. A square matrix in which only diagonal elements will be non-zero. The remaining all elements will be zeros. So except this, I will show an example. Say 1, 2, 0, 0, and 0, 5, 0, 0, 0, 6. You can see that except the diagonal elements, the remaining all elements are 0. It is called a diagonal matrix. Then scalar matrix. Scalar matrix. In this diagonal element, in the diagonal matrix, if the diagonal elements are all same, say K 0 0 0 K 0 0 0 K, Diagonal, it is a scalar matrix. It is the diagonal matrix in which the diagonal element should be same. We call it as a scalar matrix. And then next one is identity matrix. That is 1 0 0 0 1 0 0 0 1. So the diagonal elements are equal to 1. In a diagonal matrix, the diagonal elements are equal to 1. We call it identity matrix. So zero matrix, square matrix, diagonal matrix, and identity matrix. These are the different types of the matrix. Then equality of matrix. What is important here? The two matrices are said to be equal if their orders are same, and all the corresponding elements should be same. Two matrices should be equal when the orders are same and all the corresponding elements are same. Then next one is addition of matrix. It's very simple. That is, if you want to add two matrix A and B, the order of these two should be same. Add the corresponding elements. That is the addition. The same way as subtraction also will give them. Then next, multiplication by a scalar. Multiplication by a scalar. Suppose you are given a matrix, say 2, 3, minus 1, 4, 5, 0. If I want to multiply this matrix by a scalar, say 2, it is defined like this. 2 into 2, 4, 2 into 3, 6, 2 into minus 1, minus 2, 2 into 4, 8, 2 into 5, 10, 2 into 0, 0. So that means if you want to multiply a scalar to a matrix, each and every element of the matrix should be multiplied by that scalar. That is called the multiplication by a scalar. And there are some properties of addition is also there. These properties of addition. Next is properties of addition. That is, if A and B are two matrices of same order, then A plus B is equal to B plus A. This is called commutativity of addition. The same way A plus B plus C is equal to A plus B plus C is called the associativity of addition. And existence of identity, we call that 0 is the additive identity in the normal number case. So here in the matrix case, 0 matrix is the identity of matrix, additive identity of matrix. 0 matrix means all the elements should be 0, then it is called a 0 matrix. Then additive identity, then existence of additive inverse. That means when A is the matrix and minus A is another matrix, then we will be getting the total as 0. So we call this one as the additive inverse of the matrix A. So these are the normal properties in the real number. The same properties are followed for this addition also. So properties of addition. Then next one is multiplication of matrix. That is very important. Two matrices. When you want to multiply two matrices, there will be some conditions. Suppose A is a matrix of order, say A is a matrix of order m by n, and B is another matrix of order n by p. Then the multiplication is defined. So when we start defining the multiplication, you should there is some conditions to be followed. That is, the number of rows of the first matrix should be is equal to number of columns of the number of columns of the first matrix should be equal to number of then only the multiplication of the matrices is defined. And this product is the, after multiplying this one, the answer is an m by p matrix. When m by n matrix and n by p matrix is multiplied, you get an m by p matrix. And how that elements are coming is, you should multiply the row of the first matrix to the column of the second matrix. Let me take a simple example and explain you. Say A is equal to 1, 2, 3, minus 1, 0, 4. And this is what type of matrix? 2 by 3 matrix. And suppose B is equal to a matrix of say 3, 4, 0, 4, 1, 5, 2. What is the order of this matrix? It is 3 by 2. So a 2 by 3 matrix and a 3 by 2 matrix. The number of column of the first matrix is equal to number of rows of the second matrix. So here 2 rows are there and 3 columns. Here 3 rows and 2 columns. So when you want to multiply this matrix, this is one important concept here. You have to multiply this row with this column. That gives first element. This row multiplied by this column. How much it will get? 1 into 3, 3, 2 into 4, 8, and 3 into 5, 15. This is the first element of the product. And then this row into the second one. That is 1 into 0, 0, 2 into 1, 2, 3 into 2, 6. So it over to the second element. Now the second row multiplied by the first one. So minus 1 into 3, minus 3, 0 into 4, 0, and 4 into 5, 20. And this row into the second one. That is minus 1 into 0, 0, and 0 into 1, 0, and then 4 into 2, 8. So finally this answer is 8 plus 3, 11, plus 15, 26. And here 8, minus 3 plus 20, that is 17, and 8 here. So this is the way we find out the answer. So remember, the row is to be multiplied by the column. That gives one element. Then this row into second column, it gives the second elements. Remember, when you want to multiply, the number of columns of the first matrix should be is equal to number of rows of the second. This is the multiplication definition. And there are some properties also here. And that property is that you can AB is need not be equal to BA. In many cases, normal multiplication we can say that AB is equal to BA, commutative multiplication. But here AB need not be equal to BA. That is one thing. And if A into BC is equal to AB into C. So this is associativity of the multiplication is true, provided the multiplication should be defined. Multiplication should be defined means when you want to multiply these two, the number of rows, number of columns of this matrix should be equal to number of column of the number of column of B should be equal to number of rows of C. So multiplication should be defined. Then the associativity rules follows. And one more property is that the existence of an identity, existence of multiplicative identity. AI is equal to IA is equal to A. We call this I as the identity of multiplication. AI is equal to IA is equal to A. This is some of the properties of the multiplication. And then transpose of the matrix. You know that transpose is defined as a matrix obtained by interchanging the rows and column of a matrix. It is called the transpose. For example, A is equal to 2, 0, minus 1, 4. So its transpose is interchange the rows. The row is 2, 0, that will be put in the column, and minus 1, 4. 2, 0 become column, and minus 1, 4 become column. So rows and columns are interchanging, equal to transpose. And another property is that and skew symmetric matrix. Symmetric, skew symmetric. A matrix is said to be, a square matrix is said to be symmetric if A transpose is equal to A. A square matrix is said to be skew symmetric if A transpose is equal to minus A. A symmetric matrix means A transpose is equal to A and A transpose is equal to minus A. So symmetric and skew symmetric matrix. And then other things which you should remember is that any matrix can be represented as a sum of a symmetric and skew symmetric matrix. That is, A is equal to half into A plus A transpose plus half into A minus A transpose. This is a symmetric matrix and this is a skew symmetric matrix. So any square matrix can be represented as a sum of a symmetric and a skew symmetric matrix. When you write half of A plus A transpose, that gives the symmetric portion, and half of A minus A transpose, which gives the skew symmetric portion. When you put together, you will get it. So question may be asked from that area, that is, represent a square matrix as a sum of a symmetric and skew symmetric matrix. And then inverse of a matrix. If there exists, if A is a matrix, square matrix, and B is another square matrix, so that AB is equal to I, we call that B is the inverse of A. If AB is equal to I is equal to BA, we call that B is the inverse of A. That is the definition of the inverse of the matrix. Then the next level is the elementary transformation. There are three elementary operations, transformation or operation we call it, transformation or operation, both are same. There are three elementary operations, that is interchange of a row or column, CI, this will be marked like it. When you interchange the two rows or two columns, that is called one of the elementary operation. Then Ri is equal to K into Ri. Multiplying a row by a column, a scalar, or multiplying a column into a scalar. It is called the secondary elementary operation. Then third elementary operation is that is writing R1 RIS Ri plus K Rj. That is, to any row a scalar multiplication of another row is adding. The same thing is applicable for the column also. Ci plus KCj. Here, to any row a scalar multiplication of another row is added. Here, any column a scalar multiple of another column is added. These are the three operations. Here for rows and this is for the column. We call the elementary row operations and this we call elementary column operation. So they are called the three elementary operations: interchanging the rows, or multiplying a row by a constant, or to any row a scalar multiplication of another row is adding. This is called elementary row operations. And then finding the inverse by elementary operations. Inverse by elementary operations. What are the steps to be followed for elementary operation is A is equal to IA. You know that A is equal to IA, where I is a identity matrix. Now we apply a series of elementary row operation to convert this A into a unit matrix. or identity matrix. So when you do the operations, elementary row operation here, correspondingly elementary row operation should be done for I. So that this I will be changed to another matrix. So finally, after doing a series of elementary row operation, you will get a result I is equal to, it will be another matrix BA. So the product is equal to I. Then B is called the inverse of A. That is doing a series of elementary row operation. The same way you can write A is equal to AI. If you want to do the series of elementary column operation, then you should write A is equal to AI, do the elementary column operation to A, and the same way the elementary column operation to I. So that finally when it reaches, it becomes I is equal to AB. So B is the inverse of A. So what I will just want to say is that when you want to find out the inverse of a matrix by elementary operations, we should decide first whether you are going for elementary row operation or elementary column operation. If you are going for elementary row operation, first write A is equal to IA and then do the series of elementary operation for A correspondingly to I. Finally, your elementary row operation should be in such a way that to convert this A into an I. So that way you should decide to plan well and apply it and get it this one. That is the elementary row operation. Finding the inverse by elementary. This is the summary of this full chapter. We have already gone through it. I just want to make a brief of this one. These are the things you should remember in this chapter. And some more questions I am giving. So complete. So this chapter we have completed the